Hello, and welcome back to Learning with Lee. In today's episode, we're going to take a look at how to compare multiple C++ style strings. Now, what you'll note is that a lot of these are very similar to the C-style strings that we covered a few episodes ago with things such as strcomp and strncomp. The major difference is that rather than those being functions off in some library we have to use, these happen to be methods within the string class itself. So, for this case here, really all of these come down to this compare function or a few operators, like we showed in some of the episodes on operator overloading. To begin with, for these functions, is that you can end up comparing multiple strings, strings to C-style strings, and strings just to these sort of constant pointer strings similar to what we're dealing with here, just that they haven't been assigned to any variable yet. You can end up doing comparisons for those. There's a couple other variants on this, and we'll get to some of them down in here, but for now it's a matter of those are the primary things you can end up comparing. And similar to strcomp or strncomp, it either returns 0, 1, or -1. And possibly, depending on your compiler, it could return something else, but in general it's going to say 1 for if A is greater than B, -1 if A is less than B, and 0 for if they are the same. And that's an important thing to note, is that if it's 0, they are identical. However, if I have some sort of if statement here of like A dot compare B, so as if that's the case and I want to do something, what's important is that I have to actually do equals 0 in here if I want to say that they're the same. Because otherwise, this right here will succeed whenever they're not the same, whenever they are different. So that is an important thing to remember. If you want to check if they're the same, include the equals 0. If you want to check if they're different, don't. But it's going to be somewhat different compared to when we get down to these different operators that exist for comparisons. And that is an important thing to note about this, as well as also things such as strcomp and strncomp that I didn't overly go much into. I discussed that the return value is 0, but I didn't really emphasize how important that is when you're dealing with logic. Because when it comes to logic, if what you're getting out here is 0, so if I did say something like this, and then I did, okay, I care about getting out T or F, the major thing here is that normally this would be if this statement is true. However, it being true implies that the two of them are the same. Whereas, in this case here, that actually doesn't end up working. And one of the reasons why you see this error here with endl, and we'll get into this when we get down to these comparisons down here also, and that's that this operator here has fairly high precedence and ends up taking place over a lot of these different ones in here for the ternary operator I was showing there for comparisons, or these operators down here. So if I get rid of these parentheses here, all of a sudden it's going to give me this error for endl, even though it's like, what are you talking about? This clearly should be something I can do. But that's because this operator here takes precedence over this operator here, so it tries to do this section first before this section here, unless, of course, I include these parentheses to override all of that. That happens to be an important thing to consider, but then you can also do, similar to with strcomp, you had strncomp, in which it ends up allowing you to do a substring. The major difference here, and to a certain extent it didn't matter as much when we were dealing with C-style strings, is that with C-style strings, since they're all pointers, such as this one here, I could compare from, say, this S here to this G here by merely offsetting the first pointer to C. So basically going C plus 2 to get this S. And I could do a similar thing for whatever I was comparing it to get its appropriate substring. In this case here, there's a few different ways of doing this. The first one is this one that you can see right here. And the important thing with any of these is that you start off with these two numbers, and basically this is saying, okay, I'm going to take a substring of D, starting at character either 0, and D is this little test up here. And that happens to be either starting at 0 or starting at 5. So either starting at this T, which is 5, or this T, which is 0, and going for 4. So either this test or this test for these first two here. This one here is purely here to demonstrate the fact that it will succeed even if you give it some arbitrarily large number that goes well beyond the end of your string. That said, in case you end up dealing with C strings in here, once again, they do need to be null terminated, so be careful with that in case you do supply any. But The important thing about this is that it only takes the substring on D. It leaves A or whatever else you supply over here alone. So in case I did some substring and I just wanted to compare the first letter in each of them, or if I wanted to go, okay, let's head on over to this T here and see whether this one happens to match up with A, that's not going to succeed. Unless, of course, I then, let's say, and we take a look down here, and this is the more full version of these three here, in which now we're taking a substring of A as well. And basically, you can see here sort of how it ends up being applied. We have these two numbers to tell us which indices we want the or more accurately, this isn't necessarily an index for the second one, it's a count. It tells us how many characters we want to compare. In this case, I'm just comparing the first character of D to the first character of A. Because this portion here tells me I want to start at index 0 in D and take the first character, or more accurately, the first one character, whereas in this case here I want to start at position 1 and take the first 3 characters from that position onward. So it would give me these 3 characters here. And then for A doing the same thing, it would give me these 3 characters here. So that's how I can end up doing these substring comparisons without really worrying, and it ends up being the exact same as compare in terms of returning negative ones, zeros, or ones. Then, as I mentioned earlier on, we have these comparison operators. Now the important thing to know is that you see these zeros and ones down here, and you see these ones up here. These comparison operators will not return any negative numbers ever, unless I did something weird like multiplied it by -1 after getting the value out of the comparison. It'll either return 0 for false or 1 for true. And that means that if I do something such as if A equals B, then I'm going to expect 1 for it to be true, and I'm going to expect 0 for this to be false, which of course is completely different than what we were dealing with up here. So this comparison here returns a different return value than this compare up here, because this one here will return 0 if they match, whereas this one will return 1 if they do match. So that ends up allowing us to see that there happen to be some potential pitfalls and problems depending on which one you're using. So whenever you end up doing one of these comparisons with a string, whether you use the compare function or method, or whether you happen to use the existing operators for strings, you have to be certain that you actually end up either checking that it's 0 or checking that it's not 0 appropriately. And that can end up leading to the general problem that occasionally you'll be like, okay, I can compare them. This should be true in case they are equal and false if they aren't. But for legacy reasons, due to the way in which a whole bunch of existing C code existed already, Stroustrup designed it so as that compare acted the same way as the existing C code did. And the primary reason was so as that people who already had thousands of lines of C code could just go through and replace strcomp or strncomp with these compare methods and not have to do anything else to their surrounding logic. It of course screws everything up for people who get used to things such as C# and Java, which are much more logical than C++ is about this, in which if they match for this comparison, it returns true, obviously. But yeah, that is an important thing to note. And as you can see, we have less than and greater than, we have less than or equal to and greater than or equal to, as well as we also have the not equal to operator. And these are all the different comparison operators that you have for strings, so it does give you a fair amount of flexibility in terms of how you want to compare these, how you want to check these out. And basically this is sort of thing like here is just doing the same thing as this compare here, just then seeing, okay, is the value I get out of it negative in case it happens to be this less than, or is it positive, which would be the greater than. Though there may be a bit more that we can cover regarding strings and how you can compare them, the fact of the matter is that all those other methods for those comparisons happen to be similar to these methods that we've already covered, and they're just slight variations on what we've already shown here. So there's not really anything else with comparisons that we're going to go over with this, and we're just going to leave this alone until it comes up in the course of future programming projects as we end up needing these comparisons. So, thank you very much for watching. Have a wonderful day.